One of the major objectives of Indian space program has been to achieve self-reliance in developing and launching of its satellites. The Indian Space Research Organization, ISRO, develops the space technology that provides space-based support to various national tasks. The INSAT and the GSAT series of satellites cater to our assorted needs of communication, like TV broadcasting, mobile communications, video conferencing, distress alert services, disaster management and meteorological services. Whereas the IRS series of satellites are meant for resource monitoring and management. A nascent addition to the Indian space system is the IRNSS, which shall focus on the National Navigation Services. The latest satellite from the clean rooms of ISRO is the GSAT-6 spacecraft. GSAT-6 is a member of the legendary club of the Indian National Satellite System, known as the INSAT family. The INSAT, or GSAT satellites as we know them, are considered as the backbone to our satellite-based communication services. The GSAT-6 is presented with a host of new and contemporary features. GSAT-6 is a S-band satellite. It will provide communication services in S-band within the Indian mainland through its multi-beam coverage facility. The satellite to be used by strategic users. GSAT-6 will be located at 83° east longitudinal location at a height of 36,000 kilometers from the Earth. The S-band payloads of GSAT-6 are designed and developed at the Space Application Center, Ahmedabad, in order to provide communication links for voice, video, data, and maps to strategic users. The payloads are using a 6-meter S-band unfurlable antenna and a 0.8-meter C-band antenna. Other advanced feature of the satellite is its 70-volt bus, which is flying first time for the Indian communication satellite. The ground segment hardware consists of ground communication equipment along with hub and umbrella network management system that provide connectivity between the users in different beams. For the strategic users, this will ensure a seamless 24/7 and a reliable communication in any weather condition. In addition, during a natural calamity, for instance, this satellite will provide cutting-edge technology to India and put the satellite-based communication to the newer heights. It would be interesting to know that one of the special and advanced features of GSAT-6 satellite is its 6-meter S-band unfurlable antenna. This is the largest satellite antenna realized for the INSAT or GSAT by ISRO. Building such a huge antenna called for special skills and efforts from our scientists and engineers, who introduced the element of unfurlability in an otherwise conventionally rigid antenna. Larger the size of satellite antenna, better is the transmission and lesser is the need of power, which eventually increases the effective life of a satellite. The antenna shall be utilized for 5 spot beams over the Indian mainland. The 982 kg satellite is assembled at the ISRO Satellite Center, Bangalore, in its state-of-the-art facility. The satellite will have a lift-off mass of 2,117 kilograms. Once fully assembled and tested, the satellite reaches Satish Dhawan Space Center, the spaceport of ISRO at Sriharikota. Here, it again has to pass through few more checks before it is finally integrated with the launch vehicle. Majestically standing on the launch pad and looking high is the geosynchronous launch vehicle of ISRO, a 3-stage launch vehicle system designed to launch 2-ton class satellites into geosynchronous transfer orbit. The first stage of the launch vehicle consists of a solid core with 4 liquid strap-on motor. The second stage is a liquid stage, and the upper stage uses cryogenic propulsion. The cryogenic upper stage of GSLV carries 12.5 tons of cryogenic propellants, namely liquid hydrogen and liquid oxygen, in 2 separate tanks. The liquid oxygen is the oxidizer and is stored at -183 degrees Celsius, while the liquid hydrogen is stored at -253 degrees Celsius. These fluids at such low temperature are preferred due to their ability to produce maximum thrust and energy that is required to carry heavier payloads to the orbit. You may recall that developing our own cryogenic engine was taken as a challenge by a scientist and engineer, which then turned into a mission for them by putting in unremitting efforts. Today, we have GSLV D6, which will be the 9th flight of the geosynchronous satellite launch vehicle of ISRO and the 3rd flight with the indigenous cryogenic stage of our country. Let's recall the words of Dr. Vikram Sarabhai, the father of Indian space program, who some 53 years back had this to say.
In my opinion, the aspect of space research which I would like to stress most is in relation to the national capability, the self-confidence that this will generate. And if I were to give my own evaluation of this, I think the benefits of these far outweigh all the rest that we have been talking about.